Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 3-1 solving systems using tables and graphs. Now the one thing we need to remember is that the solving systems portion is going to be basically us talking about two different linear functions, and we're going to be trying to decide whether or not we can figure out what the x value and the y value are in both of these that allow these statements or these functions to be true. Let's get started. First, we're going to start off with a little bit of vocabulary. Can we cross out the equation that is not in slope-intercept form? Well, in order for something to be in slope-intercept form, that means it's going to be basically the y equals your mx plus b form. Now, just because we don't see an m or we don't see the b doesn't necessarily mean it follows into that it's not a slope-intercept form portion. It can be written in any way, shape, or form like this, then it's going to be considered slope-intercept. So looking at the very first one, we get y equals a negative 1 over 7x. Well, if I were to add 0 to it, it would look just like this, and therefore it is. We're good. We have the r equals s. Well, if we consider the r to be y and the s to be equal to x, then we can see that this is just the same thing as 1x plus 0, which is going to be the y equals mx plus b, which means this works. This is okay. All right, a equals the square root of 3 times b plus 5. If we were to change the a to a y value and b to an x value, we're going to get the y equals mx plus b, where the m is going to be the same thing as the square root of 3. All right. So again, that's slope-intercept form. However, the final version, we get that ax plus by form equals c, which is that standard form, and therefore the final version, the final equation that we have is actually not slope-intercept form. But like I said before, today we're going to be talking about the linear systems. So you have different types of linear systems. You have the independent system or the dependent system. All right? A linear system is a collection of linear equations involving the same set of variables. The system above is two equations in two variables. Notice we have two different equations, equation 1, equation 2, but more importantly, we also have two variables. You have your x variable, which is right there, and your y variable, which is right there. And that's all that basically we are going to use to create these linear systems. So let's use the vocabulary. The graphs below show the possible types of solutions for a system of two equations in two variables. Write T for true or F for false. Well, we can notice that if it's a one solution problem, meaning it intersects one time, or the intersecting lines, all right, we have something that is going to be considered consistent because it does in fact have some sort of answer that is accurate. It's where they cross this point is going to be the solution. That is the proper x and y point, all right? But it's going to be independent, meaning both of these lines doesn't really rely on the other line. It's just a random line that happens to cross, and they both seem to cross paths right there. More importantly, this right here will be the answer, all right? The xy point that we're worried about. All right. Now, in coinciding lines, that basically means that we have infinitely many solutions. In other words, it's going to be consistent because we have a solution. It's just we literally have all of the solutions. All right. Infinitely many solutions means that no matter what value we plug in, we're always going to get the exact same answer. And that's why it creates just one line. All right. But it's going to be considered dependent because, well, one line is dependent on the other. If we know that it hits infinitely many times, it means that if we were to change one portion of the one line, we would have to change the other portion of the other line in the exact same fashion to make sure that it stays the same. And then at last but not least, you have the parallel lines, which is no solution because they never touch, all right, which makes it also inconsistent. So let's get going. So question number 2, inconsistent linear systems intersect at 2 points. Well, in order for something to be inconsistent, that means we can't have a single solution that is correct, and therefore that is going to be false. An independent linear system has one solution. Well, this is in fact independent, and we do in fact have, well, one solution. Therefore, that's true. A dependent linear system has no solutions. Well, that's actually the opposite, right? So dependent has an infinitely many amount of solutions. It's just every solution is correct. Therefore, this is going to be false. And two unique lines that have the same slope form an inconsistent system. That's just a fancy way of saying, hey, if we have parallel lines, it's inconsistent. And in this case, that is true. Great work. Using a graph or table to solve a system. What is a solution of the system? The system that they give is going to be that x minus 2y equals 4 and the 3x plus y equals 5. So question number 6. Circle the graph of the equations. If I were to take this system right here and plug it into Desmos, we would get something that would look very similar to this. And if you notice that if you pay attention to these graphs, you'll notice that they cross, and more importantly, where they're going to cross is going to be crossing down in the fourth quadrant. So I'm going to take a look in which one of these graphs cross in the fourth quadrant. Well, this point is in the first quadrant. This point is also in the first quadrant. So the only graph that seems to have them intersecting in the fourth quadrant is going to be the final graph, and that's exactly the correct answer. So circle the row of the calculator that contains the solution. Well, if we were to type this into our calculator, you would basically be looking for when the y values match up, because all of these x values are the same. So in this case, the y values that match up happen to be at the 2, -1, which is right there. So the solution to this system of equations will be the x value of 2 and the y value of -1. Problem 2. Using a table to solve a problem. See, the equation y sub 1 equals 1.5x plus 22 models the length in centimeters of a spiny dogfish shark x years old. The equation y sub 2 equals 0.75x plus 37 models the length in centimeters of a Greenland shark x years old. If the growth rate continues, how long will each shark be when it's 25 years old? So my first question is, which shark will be longer at age 25? And how do you know? Well, if I had to take a look at this, you're going to notice that one's going to start off relatively smaller, at 22 centimeters, but it's growing at a substantially faster rate than the other. So this is going to start at 22 centimeters, but it's going to be growing significantly faster because we're increasing at 1.5 each and every time. And for the other version, we're going to start off relatively larger with 37 centimeters. However, we're going to be growing at half the rate. So if looking at just that data, I'm going to go straight up and say that the spiny dogfish will actually have a faster growth rate, so it should be longer at the age of 25. But how do we go about solving this one out? Well, let's underline the correct phrase, complete each sentence to solve the problem. I need to find an x value or a y value or two x values or two y values. Well, you're going to have to find two y values. You need to find the end result for both of them. We need to find the end result for the dogfish as well as the Greenland shark. So let's complete the table for x equals 25. So if we know what the y value equals, we can just plug the 25 in to the equation and then it will spit out the answer. So 1.5 times 25 plus 22 is going to equal 59.5. Well, if we do the exact same thing for the Greenland shark side and change that x to a 25, we are then going to get 0.75 times 25 plus 37, which will give us 55.75 centimeters. So the spiny dogfish shark will be roughly 59.5 centimeters long, and the Greenland shark will be roughly 55.75 centimeters long when they're both 25 years old. Problem number 3, using linear regression. The table shows the populations of the San Diego and Detroit metropolitan regions. When were the populations of these regions equal, and what is the population? Well, kind of going through this, I did skip from question 13 to 15 immediately, but the answer to question 13 will be enter the data into lists, which I'm not showing you because we're not going to be using the standard TI-84 calculators. And then writing the name of the list that you will use, L2, L3, or L1, into the data type. Again, the correct one will be L2 for the population of San Diego, L3 for the population of Detroit, and L1 since 1950. Now, the one thing I would say about that is, again, we're not using the standard calculator, so that's why I'm not worried about those portions. But they will give you the same exact answer. So we need to circle the pair of equations you will graph. So looking at it, it looks like the very first one, y1, if I type everything into Desmos, and actually if you kind of zoom out, you might be able to see that we do get these massive two lines, the green line right here as well as the purple line down there. All right, both of those represent roughly the same thing, but you're going to notice that we're going to get two different equations completely. We have one that starts with a slope of positive 17,816, which looks like we're going to be doing this one right off the get-go. And the other one has a negative slope of negative 19,217.6 as well. Now, technically, yes, we should pay attention to the y-intercepts, but looking at these choices, the only one that has a positive 17,000 and a negative 19,000 is the first choice given. So we can circle that. Now, this is where it gets a little bit interesting. Because using that information, we need to underline the correct word or words to complete each sentence. So the x-axis or y-axis corresponds to the number of years since 1950. Well, if I were to look at what I did, my x value is going to be represented with 0, 10, 20, 30, 40, and 50, which means that those are the years since 1950, so it's going to be the x-axis. The y-axis then corresponds to the populations of San Diego and Detroit, San Diego being y1, Detroit being y2. The scale of the graph is negative 60 to 60 by tens, and 0 to 1,500,000 by hundreds of thousands. So let's take a look at what this would look like if we were to scale that graph appropriately. So the x went from negative 60 to 60. There we go. And we're increasing by tens each and every time. And then we had our other y value, which was starting at 0 and increasing to our 1.5 million. So I'm going to start at 0, and we're going to increase to the 1.5 million. So 1500000, and we're going to be doing a step of, I believe, 100,000. And you'll get something that looks very, very similar to this. Only in this case, we're going to be using Desmos, so you can see it where it looks like this on Desmos, whereas on your normal TI-84, it might look something slightly different. All right, so taking a look at that, the coordinates where they will be intersecting is going to be at this point right here, which, as you can see, is going to be somewhere around the 40 x value-wise, and it looks like it's going to be 1,074,919, and they might end up changing that to something slightly different. So our coordinates will be, in this problem, 40.3, which is what we have, and then it should be the 1,074,919, which again is what we received right here. All right. Again, the points where they end up intersecting will be the correct answer. So the population of San Diego and Detroit are equal sometime during the year. In this case, it's going to be the 1950. Because that's our starting point, but then we're going to add the 40 years on top of it, which will give you somewhere in the 1990 region. So it's going to be during the year 1990, and the population will be roughly 1,074,919. And now technically it's going to be roughly 1,075,000 what they're going to put. But if you wanted me to go through the actual population legitimately, and we said that this is 100% accurate, then we would actually bump this 919, we would actually bump that up to a 920, because that 0.148 of a person is still a full person. Problem number 4, classifying a system without graphing. Without graphing, is the system negative 3x plus y equal 4 and x minus 1/3 y equal 1 independent, dependent, or inconsistent? Can we write the equation in slope-intercept form? So, in other words, can we solve for y? Can we get y by itself? Well, the first one, I'm going to add 3x to the other side, and you're going to get that you have y is going to equal 3x plus 4. So the first step I'm going to do is subtract x from both sides, and you're going to get a negative 1/3 y value is equal to a negative x plus 1. Well, I need to move that negative 1/3 over, so I'm actually going to multiply that by its reciprocals, which is a 3, but since this is negative, I'm also going to multiply it by a negative 3, so that the 3 cancels out the 3 on the bottom, the negative cancels out the negative, and I'm left with just a y value. And if I do that to one side, I must make sure I do that to the other, so I'm going to multiply by a negative 3 on the outside of the other side as well, so we get negative 3 times a negative x, which gives you a positive 3x, kind of like this one, and we have a negative 3 times a positive 1, which will give you that negative 3. So the slope of a negative 3x plus y equals 4 in standard form, well, when we wrote it in slope-intercept form, we found that the slope is going to be 3. And if you write the slope of this function right here, that x minus 1/3 x equals 1, if we put that into slope-intercept form, you're going to find out that, again, we get the same slope of 3. So the y-intercept of the negative 3x plus y equals 4 is going to be our 4, because that's what we found it to be. And the y-intercept of x minus 1/3 y equals 1 is going to be negative 3, because it's in the b portion of the y equals mx plus b. So it should be negative 3. So can we underline the correct words to complete each sentence? Well, because the slopes of these are going to be both equal, because both of them are 3, and the y-intercepts are different because one was 4, the other one was negative 3, then this system is going to be considered inconsistent, because these lines will actually be parallel lines, meaning there will be no solution. Since there is no solution, it's going to be considered inconsistent. Remember, independent is one solution, and dependent means that they're the exact same line. I even write same line. And we finally made it to the lesson check, the very last little bit, guys. So let's figure this last little bit out. Is it possible for a system of equations to be both independent and inconsistent? And can you explain? Well, the graphs of an inconsistent system are parallel. Well, that's true. The graphs of an independent system intersect at one point. That's also true. And therefore, since we know that in order for something to be independent, it has to cross at one point, we also know that parallel lines never cross. We can say that our answer is no. Inconsistent lines are parallel and never intersect, and independent lines have one point of intersection. Therefore, a system cannot be both independent and inconsistent. Great work, everybody. I hope everyone has a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you guys in the next one.